In this lesson, we want to derive the labor demand curve. The labor demand curve, as you may remember, is a downward sloping line describing how much labor will be demanded in a market at different wages. We describe this labor demand along with labor supply, which in this picture is the blue line, which is upward sloping. Remember, in labor supply and labor demand considerations, when we're looking at labor markets, on the horizontal axis we put the quantity of labor employed by the firms in the market, and the vertical axis we put the wage. So it's not just the quantity of output on the horizontal axis, it's the quantity of labor. So this is a model or a theory that's going to talk about labor markets, people deciding how much to work, how much not to work, firms deciding how many workers to employ. It's going to have implications for unemployment. It's going to have implications for what wages are, why they grow over time. It's a fascinating model, and what we're going to argue is that the same concepts of supply and demand that applied to oranges or grapes or whatever in previous lessons can apply to the labor market, can actually apply to people, not just to goods. As we've drawn this, you see the intersection of labor supply and labor demand, and that's our prediction of what the total quantity of labor in the market will be, amount employed, and we also have a prediction of what the market wage will be. Whenever you draw a picture like this and think about a labor market, you got to think about what market you're talking about, because there's many different types of labor. There's skilled labor, there's unskilled labor, there's labor for markets for teachers, there's markets for mechanics. And so we're going to consider more of a generic market here, a quantity of labor supplied for maybe a particular group of unskilled workers in a particular area. Anyway, it's a fairly well-defined market that we can focus on. Now, what we want to do now is not just consider those curves, but try to derive where they came from. Look at the underlying features of where they are. And when we do that, we're going to get many more interesting conclusions than we can get simply by looking at the curves themselves. So when we derive the labor demand curve, which is the subject of this lesson, we want to think about what's underlying that curve. In general, the labor market has two sides. It has firms hiring workers, and it has the workers supplying their labor, their actual work. The labor demand, that downward sloping line, is therefore going to be the decision of the firm, how many workers to employ at different wages, the quantity of labor demanded at different wages. The blue line, which we'll come to in the next lesson, labor supply, is really based on the worker's decision. So when you think about where these curves come from, you got to think about firms or individuals. In the case of labor demand, it's the firms actually thinking about this. In the case of labor supply, it's the workers or the consumers or the people. It's exactly the opposite of when we derive the supply and demand, say, for refrigerators. In that case, the supply was coming from the firms producing refrigerators, and the demand was coming from people deciding how many refrigerators to buy. Here we've switched the demand. The demand is really determined by the firm, and the supply is determined by people. So let's think now about demand, where it comes from, specifically thinking about the firms. Not surprisingly, we're going to derive this demand for labor, but going back to the basic principles of economics, that firms maximize profits. And they choose a level of output, refrigerators or whatever, to maximize profits. And when they choose this amount of output, production, that's going to imply a certain amount of labor that they need to have to produce the refrigerators. We're going to be thinking about this in a short-run concept where the amount of refrigerators that are produced depends only on the amount of labor that goes into producing the refrigerators. You could, of course, have more capital, better machines to help to produce the refrigerators. We're going to think of those as fixed for the time being and only consider the change in the labor, because that's what we're focused on. So it's kind of a short-run consideration. If the firm wants to produce more, how many workers will it hire? And when we do this, we want to go back to this concept of the production function, which simply tells you how many workers it takes to produce certain amounts of output. How many workers it takes to produce one refrigerator, how many to produce 7 refrigerators, etc. And of course, that's the production function, which we talked about earlier. So let's look at a basic assumption that we're going to be using to make this work. Not only profit maximization, but we're going to try to start on the competitive situation. is two concepts of competition to think about when you think about labor demand. One is the market in which the firm sells the goods, where it's selling the refrigerators or the apples or whatever it is. We're going to assume it's competitive, so the firm takes the price as given in that market. Gone through what that means. It's a competitive market. The firm really can't influence the price very much. Takes the price as given. But in addition, there's also going to be competition in the labor market. We're going to take as given that the firm takes the wages given. That's part of our assumption. So the firm will be deciding how many workers to hire, say in a fast food restaurant, or how many workers to hire to produce refrigerators, given a given wage for whatever it is, the workers that are working in fast foods or the more skilled workers that are producing the refrigerators. Take that wage as given. That's the competitive assumption. Both can be changed if there's monopolistic power or market power, but for now we're going to have just competition and see what the implications of competition are. Let's give an example of how this works then. Consider a firm that's producing different amounts of quantity of output and different amounts of labor input, different amounts of workers. First column shows you what you get from 1 worker, 2 workers, up to 5 workers in this example. For example, you get 17 units of output for 1 worker, 51 units of output for 4 workers, etc. That's the quantity produced. The third column shows you the marginal product from hiring additional workers. We've considered this before. The marginal product tells you how much additional output is produced as you hire more workers. So for example, as you move from 0 to 1 worker, the marginal product is 17. As you move from 1 to 2, the marginal product is 14. That's the difference between 31 and 17, and so on. So know that marginal product declines. That's the notion of diminishing marginal product, which is common to production functions. And the production function itself is just the first 2 columns. Remember, the production function tells you how much output you get, how much quantity produced you get for a given amount of workers. Now let's go to think about the revenue that the firm gets. The firm's going to maximize its profits, remember. To get revenue, if the price is $100, which is being assumed here, the price of the product is $100, you just multiply that price by the quantity produced. So for example, for 1 worker employed, you produce 17 units. At $100 a unit, it's $1,700. Go to the bottom row of the table. If there's 5 workers and the production is 58 units, multiply by 100, you get $5,800 of revenue coming into the firm. Price times quantity is revenue, and there you see it right there in the 4th column. Now, the new concept, which we want to look at to get the labor demand, is the 5th column. It's just it's called marginal revenue product. Marginal revenue product, by definition, is the change in the total revenue that occurs as you hire an additional worker. So, for example, total revenue goes from 0 to $1,700 as you hire 1 more worker. That's $1,700 marginal revenue product. Go down to the bottom part of the table. As you increase the number of workers from 4 to 5, your revenue goes from $5,100 to $5,800. Your marginal revenue product is $700. The difference, the increase from $5,100 to $5,800. Marginal revenue product, note, is different than marginal product. Marginal product is the 3rd column. Marginal revenue product is the 5th column. Marginal revenue product is what we're going to use to derive the demand curve, and I'm going to show you that with a simple little diagram. And the simple little diagram is going to do nothing more than plot the 1st column and the 5th column, number of workers versus marginal revenue product. So let's set up a diagram to do that. The diagram is, as I said, going to have 2 things plotted. On the vertical axis and the horizontal axis, we're going to have different things. So on the horizontal axis, we'll have the number of workers. So that's, in our example, 1, 2, 3, 4, 5. And let's call that L for amount of labor input. In the vertical axis, we're going to produce and print the marginal revenue product. So that has a range, let's say 1,000 there, 2,000 there, put in a 500 there maybe, a 1,500 here. And so now I want to just mindlessly plot the numbers from that table of marginal revenue product and the number of workers. So for one worker, you recall the marginal revenue product was 1,700. For two, it was 1,400. For three, it was 1,100. For four, it was 900. For five, it was about 700. Okay, those are just the marginal revenue product amounts. Now, if you were a profit maximizing firm and you were deciding how many workers to hire, you would compare that marginal revenue product with what you had to pay the workers. And when we do that, we're going to get the demand curve for labor. So let's think about it. Let's consider, for example, that the wage of labor is $2,000. The marginal revenue product, the additional revenue you get from hiring a worker, one worker in this case, is $1,700. If you had to pay $2,000, let's say this is a week, for example, you have $2,000 a week for a worker, and the workers only could produce revenue of $1,700, you say, no, I'm going to lose money if I hire that worker, so you won't, so you hire no workers. And that's going to be true for all wage levels up to $1,700, or a millicent less than $1,700, in which case they'll shift over and hire one worker, because it's now worth it. When the wage is above $1,700, you don't hire that worker. When it becomes equal or lower, then you will. And then you could lower it further. Suppose it's $1,500. What's the wage is $1,500. Well, then you're still going to hire one worker because $1,500 is higher than $1,400. You would pay more at that wage of $1,500 than the marginal revenue product you get. So you'd basically just come down this line and then zoom over to that line when it became $1,400. And similar here, if the price of the wage for labor is in that region, you hire two, but then it jumps over when it becomes, in this case, $1,100, and so on. That'll be the 900, and that's the 700 going down the curve. So what you have here is a relationship between the wage, which is over there, that's right, in wage, in the market that the firm is taking as given, and the amount of labor that the firm hires, number of the workers that the firm hires. It's downward sloping. As the wage falls, more workers are hired. And as is often the case in these numerical examples, the curve looks like steps rather than a smooth curve, but if you could imagine you could hire workers by the hour rather than by the week, you could basically think about drawing a smooth line through those points, and effectively what you're getting then, this smooth line, is a now typical looking labor demand curve for a single firm. Again, what we plotted is the marginal revenue product, and that is the demand curve. So when you think about a demand curve for labor, think marginal revenue product, because that's what economists do. Now let's, given this, think about what we have gained in considering the problem this way. First, we've seen there's a condition for profit maximization. It is that the firm sets the amount of employment such that the marginal revenue product is equal to the wage. Those are the dots in the picture. And so we have a simple little formula. Marginal revenue product equals the wage, and that's a condition of profit maximization. It's also derived the labor demand curve. In addition, if the firms are in competitive markets, the marginal revenue product is simply the price times the marginal product. So you can think of the marginal revenue product, if it's 1,700, that's just 100 times 17. Or if it's 1,400, it's 14 times 100. So marginal revenue product is as indicated here, price times marginal product, and that's going to be a way for us to test whether this theory actually fits the facts or not. Let's now consider what happens to get the market demand curve for labor. What we've done so far is derive the demand curve for a single firm. But of course, in a market, there's lots of firms demanding labor. There's lots of fast food restaurants deciding how many workers to employ. So to get the market demand curve in that market, we want to find what the sum of all the firms' labor demands are. And this picture is an example with just two. So there's two labor demand curves, actually much like the one that were just derived. There's firm one and firm two. Firm one, we have on the vertical axis the wage and the quantity of labor of that particular firm demanded on the horizontal axis, and there's the downward sloping labor demand curve derived just like we did with the numerical example. Firm 2 is the same thing. It doesn't have to look so much the same. They're not exactly the same in reality, but it's basically whatever it happens to be. And then to get the demand curve for the market, we just want to sum across in this picture. So for example, if their wage is down at 100, in this picture we're going to get a quantity of labor of 9 for firm 1 and a quantity of labor demanded of 9 for firm 2. And so we go across and sum those together and we get 18 for that particular price, for that particular wage, the price of labor being the wage. You do the same thing at any other wage, so maybe 1,000, you drove across here, add horizontally, you add that number to that number, and you get the sum of the two firms. So the market demand curve, again, is just the sum of the demand curves for each firm, and we're summing these horizontally. It kind of is like to think of this as summing horizontally, which I think is pretty obvious from the picture of how you get it. So that's the labor demand curve. And again, what we're getting that labor demand curve from is simply the assumptions of profit maximization for the individual firms in the market. You might just ask, is the story much different if the firms have market power, that is like a monopolist? Well, not really very much. The only difference here is that when the firm produces more, the price will go down. The firm is not a price taker as in the competitive market. So higher production will reduce the price, and therefore when you compute marginal revenue product, which is the price times the quantity, it'll be a little different. But we still must have marginal revenue product equal to the wage as a condition. And the only thing is, in this case, marginal revenue product will not equal the price times the marginal product because price is not fixed. It varies depending on how much you produce and therefore depending on how much labor you hire to produce that. So more specifically, P will decrease if Q rises and L rises. But otherwise, it's exactly the same. We have these conditions for labor demand based on marginal revenue product considerations, and that is equal to the wage. So thank you very much for this discussion. We're now going to, at the next lesson, consider deriving the supply curve for labor.